Today we're gonna do an Arduino on a breadboard. Got a couple of requests for the how-to to make an Arduino on the breadboard. It's a lot cheaper than the normal retail boards. Obviously, if you're using a shield, it's gonna be a little bit more of a pain to hook up, but the benefits of breadboards are just great. You can reuse these things, and you can make them for about $10 depending on where you get your supplies from. Now, if you buy from SparkFun, the new 328s with the Arduino Uno OptiBoot loaded, they actually come with a sticker with the pinouts, which is really helpful. So that makes it real simple to wire everything up without having to reference a document. Up here on the breadboard, I shorted my positive to their positive rail on their side, negative to the other negative on the other side. I'm going to take the actual Mega 328 here and put it in the breadboard. If this is your first time playing around, just be gentle with the chip and the pins so you don't break anything. Get it situated right there on the bottom. And on the left side you'll see VCC and ground. On the right side there's also a ground and VCC. VCC is positive, ground is ground. So we're going to go ahead and wire that up on both sides. The ground on the left, and then the VCC, which is positive on the left, is the next pin up. And then on the right, the ground comes first. If you're looking from the top down, then there's a space. The pin in between. The next one down is called AREF, which stands for analog reference. If you're going to use analog pins, it's a really good idea to short that AREF pin to positive. That way it uses whatever actual voltage you get in the circuit as the analog reference of high, or else your values are going to be really weird. This first one I'm not using it, doing digital, so I'm going to leave it open. The next one down is AVCC, which auxiliary positive. So we'll go ahead and hook that up to the positive on the breadboard. And if you look on the left again, right below what you just did on the positive and negative, there's X1 and X2. X is a crystal. This is 16 megahertz crystal. You can also use a resonator. Resonator is pretty cool because you don't need to use the caps that I'm about to show you. But go ahead and slide the crystal pins in X1 and X2. And because it's a crystal, not a resonator, you need some caps. These are the 220. I believe that's 22 picofarads or microfarads. I always get them wrong, but the 220. So one pin's going to go to your X1 slot, and the other one's going to go to negative. And then you're going to need same value 220 cap for X2. Also going to go from negative to that pin on the crystal. That way she'll be working appropriately. And again, a resonator has got 3 pins, X1 and X2. On the outers, in the middle is ground. That way you don't have to have caps, but it's kind of weird to hook it up. I've used both, it's fine. The next little thing we need to do is pin the first pin, pin 0 or pin 1, whatever you want, reset, RST, reset. The reset circuit, 10K resistor, you're going to want to go from positive to the reset pin. Now, this pretty much is always necessary. I've seen a couple diagrams that says all you need is the 10K, you don't need a cap. I haven't tried it with the new Uno, if that makes a difference or not, but I do remember the old Duo Milanovo did need another cap, a 104, which I think is a 0.1 microfarad maybe. So this 104 cap, one side would be in line shorted with the resistor and the reset pin. The other side of the cap I put to the higher pin that's open, the next level on the breadboard. That's where a cable connection is going to go. So hopefully that'll be clear enough that you can see. And basically that's it. For this test circuit with the blink sketch, I'm just going to take a normal resistor, 220 ohm, connected to an LED, and put it on digital pin 13. So on digital 13, D13, put the resistor on the negative side to negative. That'll get a little LED working. Now these bare bones breadboard Arduinos communicate over FTDI, so you need to have an FTDI to USB cable. The only place, when you already get them from online, they're always like around 20 bucks, 18, 20 bucks from my experience. In this connection, you have positive and negative. You got the reset, transmit, and receive, and there's also a brown connection that's not used for the Arduino. I rig up my own custom cable just from jumper wires, and I hot glue them together in the right pin position. Leave the other side just open for the breadboard. So all you have to do is hook up positive and negative anywhere on the breadboard, since we've shorted the rails. I'm going to put them down here, but as long as they correspond correctly. Green is reset, and that's where you want it to be on the other end of that cap. So you want to have reset to one end of the cap shorted, and the next line down you're going to have resistor, other end of the cap, and reset shorted. Then the next one up is going to be orange. I can't remember off the top of my head if it's receive or transmit, but it's the D0 pin. And then yellow is the D1 pin. Again, it's either receive or transmit. I forget. Doesn't matter as long as you remember which way they go. And then you have your connector. So then I'm going to hook it up. Make sure you get it right, or else you're going to have, it could fry the board if you hook them up the wrong way. Black on one end, green on the other. And that's how I hooked them up. Is I put them in individually, then hot glued, let it dry. Now it's like a cable. So now that it's hooked up to the computer, we'll take a look at the simple sketch. This one will blink the LED and print "Hello World" to the serial. So just make sure this is the new Arduino Uno. Make sure that's on the board. My serial port's set up. Then all we'll do is hit upload. Hopefully it'll go through. Done uploading. We'll look at the serial monitor. There's "Hello World." We'll look at the circuit. There's the LED blinking. So that's it. That's all you do for an FTDI breadboard Arduino at Mega 328. Thanks for watching. Click on my ads, please.